This was an extremely helpful technique that dramatically reduced the runtime. Hello, let me introduce myself first. My name is Martin Brada and I work for Ricardo, China in Shanghai. In this trailer, I would like to present our thermal assessment of an oil-cooled electric motor. This work has been done as a collaboration between two companies, Ricardo and EngineSoft. The engineers from EngineSoft carried out a particle-based CFD simulation in order to simulate the oil flow, and Ricardo were responsible for a steady-state finite element thermal analysis and, what is important, temperature correlation with the experimental data. As you can see, the cooling layout comprised of 3 sets of nozzles at the rotor that splashed the oil onto the windings. The intention was to examine the results from a particle-based CFD software, which is still a relatively new tool in the automotive industry and is generally supposed to be most effective development tool for these kinds of applications. The process of fluid simulation actually consisted of 3 different simulations. The first one was a quick run to determine the flow split among the different sets of nozzles, so that the internal flow does not have to be simulated in the final long run. A big disadvantage of particle-based CFD software is the fact that usually just one particle size can be used in the whole domain. Therefore, it is very computationally expensive to run a simulation also with air that may have a significant effect on the flow. The software we used allowed us to pre-calculate the airflow separately with larger particles and then apply the air velocity field on the small oil particles in the final third simulation. That was the export of the heat transfer coefficient on the surfaces of the electric motor. Subsequently, the HTC map was used in the steady-state finite element thermal model that was built in software Fears from Ricardo. The temperature was monitored at 6 different points on the windings that corresponded to locations of the temperature sensors in the experimental setup. The results turned out to be very positive for us. Ricardo aimed for a ±5 degrees centigrade deviation for this kind of application, and all the points fell within this range with the largest deviation of 2.8 degrees centigrade. As a result, we consider this process feasible for simulations of oil-cooled e-machines. Thank you for your attention.